All right, in this lesson, we're going to take a look at dividing radicals. Very similar to our rules and processes for multiplying radicals. The only addition that we're going to add is when you have fully simplified, you can't have a radical in the denominator. And we're going to get into that on the second page here. So in previous work, we discovered that if I had the square root of a over b, it's the same as the square root of a divided by the square root of b. And if we add in coefficients, we can use the same process. So to divide radicals, they have to have the same index. And then I'm going to divide the coefficients, and I'm going to divide the radicands, and then I'm going to simplify. Seems pretty straightforward. So if I have the square root of 30 over the square root of 6, then that's going to be 30 divided by 6, just the square root of 5. If I have 8 cube root 21 and 2 cube root 3, then I'm just going to divide or simplify the coefficients to get 4. And then I'm going to divide or simplify the radicals to get the cube root of 7. When I get to the next example, then 15 over 10 is the same as 3 over 2. And 48 divided by 6 is going to leave me with 8. But I can see that I can still simplify this radical, which means that I'm not done yet. I'm going to simplify the radical of the square root of 8 to be, 2 root 2, which means I have 6 root 2 on the numerator over 2, and then I can divide that out again. It's going to give me 3 root 2 is my final answer. So I always need to double check about simplifying. When I get to the last example here, I can do the coefficients, and that's going to give me 1 over 3. And then I have root AB over root A. Well, the root A and root A I can take out. Root A divided by root A is just 1, and the square root of 1 is just going to be 1. So 3 times 1 over 1 and root B, which I can just call root B over 3. Just like with multiplying, in some cases, converting a radical into simplest mixed radical form will make it easier to actually calculate. So in this case, we're going to convert these before we do it. Instead of trying to divide out here and divide out here, I'm going to simplify this and simplify this as my first step, which means that this is going to give me 4 and 3 root 6 over 3 and 2 root 2. That's the same as 12 root 6 over 6 root 2, and lo and behold, these divide out evenly, and these divide out evenly. So 12 divided by 6 is 2, root 6 divided by root 3, or root 2, is going to give me root 3. And there's my final answer. Going to do the same thing for the next one. So it's going to give me 8, and the square root of 126 is the same as 3 root 14. And the square root of 112 is going to be the same as 4 root 7. So this is going to give me 24 root 14 over 4 root 7. And lo and behold, the coefficients divide out evenly. 24 divided by 4 is going to give me 6. And the radicals divide out evenly. Root 14 divided by root 7 is just root 2. Same process with example C, just be careful because they are cube roots in this case. So I'm going to get 10, and the cube root of 162 is the same as 3 and the cube root of 6 over 20, and the cube root of 128 is the same as 4 and the cube root of 2. This is going to give me 30 cube root of 6 over 80 and the cube root of 2. 30 over 80 just can get reduced down to 3 over 8. And the cube root of 6 divided by the cube root of 2 leaves me with the cube root of 3. And there is my final answer. The way that distributive property works with multiplying is the same as the way that it works with dividing. If I'm dividing, and I'm dividing out of a polynomial, then I need to divide every single term by the denominator. Which means that if I want to, I could rewrite this as root 24 over root 6 plus root 48 over root 6 minus root 108 over root 6. That's going to give me root 4 plus root 8 minus root 18, or 2 plus 2 root 2 minus 3 root 2's. And when I combine my like radicals, 2 minus the square root of 2.